All right, good evening. Hello, everyone. Welcome to the Marshall W. Allworth Planetarium. My name is Jessica, and I will be your curator to Strange Things in Space tonight. Now, if at any time during the show you have questions, feel free to ask. If you're not comfortable asking in front of a group, you can always come find me after the show. We're going to be taking a look at bizarre, strange things in space. We got some really fun things to talk about today. Now, if you do need to leave anytime during the show, you're welcome to do so. You'll just exit through the same door you came in. Just, of course, be careful because it does get dark in here. And then after the show, if the clouds held out, we will have a telescope outside to take a look at the moon or whatever else might be out. But we'll just hope the clouds stay away. I know it was partly cloudy when we came in earlier. So, yeah, that's it for me for now, so I'm gonna head to the back and we'll get started. All right. Now, our universe is full of some strange and wonderful things. Today, we're going to be taking a look at some of the more bizarre things in our universe. And we're going to start off with a couple of things in our own solar system, and then slowly make our way further and further out into the universe. So our very first stop is going to be over at the planet Saturn. Now, if we head to Saturn's North Pole, we find that there is this strange hexagon shape. Now, this is a natural feature, and we've known about it since Voyager flew past in the early 1980s. I believe Voyager 1 was the first to get a good look at it. But then our best images of it came from the Cassini spacecraft, which is the imaging you're seeing here. Now, this feature has really baffled astronomers. This hexagon that we see is like a massive hurricane with winds flowing at up to 200 miles per hour. But it's gigantic. To give you an idea, I'm going to add something for size comparison. Yeah, that's the Earth. One side of this hexagon is larger than the diameter of the Earth. It is a gigantic storm system. And we see storms in the Jupiter and Saturn, and of course Earth has them as well, but not this big and not this shape. Storms are usually circular in shape. So there's been a lot of just questions into how we naturally get a hexagon shape here on Saturn. The other big question is why we don't see the same thing on the South Pole. We only see this hexagon on Saturn's North Pole. Well, this is one of the few this evening that we do have a slight answer to. There have been a lot of tests on fluid flowing to kind of see if you could get a natural hexagon shape, depending on how the fluids are flowing relative to each other, their speeds. And so there have been lots of tests conducted doing this. And it turns out that under the right conditions, which you don't have to worry about the numbers, but under the right conditions where you have fluids flowing at different speeds, they can naturally create these little eddies that will eventually shape out a hexagon. And depending on your parameters that you're using, you can get other shapes, not just hexagons or circles. But this seems likely of what's causing it. But we still have that other question of why are we seeing it on the North Pole and not the South Pole? How stable is this? How long is it going to last? Because at least from our viewing, it's been there for, since the early 1980s. So yeah, really weird feature here that we're starting to understand, but definitely was a big surprise the first time we ever saw it. All right, heading on now over to Jupiter's moon, Io. Now, Io has a fun nickname here at the planetarium. We call it the pizza moon, because of, well, it kind of looks like a pizza. What makes Io so interesting are all of these dark specks that you see. These are actually volcanoes. Io has over 300 active volcanoes. So active that, like in the middle picture, we have got pictures of eruptions when spacecraft have flown by. We've even gotten pictures of lava flows flowing across the surface of Io. So Io is the most volcanically active object in our solar system. Now, being volcanically active in and of itself doesn't seem that bizarre, doesn't seem that weird. I mean, we have volcanoes here on Earth. We know that volcanoes exist on Mars, on Venus. What makes this so peculiar is the size of Io. See, Io is a little bit smaller than our moon. And our moon is not volcanically active. Things as small as our moon generally aren't, because in order to have volcanoes, you have to have internal heat. But small things cool off faster than big things. That's why the Earth still has a lot of heat and can drive these volcanoes, but the moon doesn't have any because it's cooled off. Well, Io's smaller than our moon, so it should also be cold inside. There shouldn't be any heat to drive these volcanoes. So something else had to be going on, because this should not be happening. Well, it turns out that the culprit here is Jupiter and all of the other moons. Now, let me finagle us around here. You see, Io here is caught in a tug of war. You have Jupiter on one side pulling Io towards it, and then you have all of the other 94 moons of Jupiter pulling back the other way, or at least enough pulling back the other way to make an impact. And so Io is getting pulled back and forth. And this pulling back and forth is causing Io to stretch and release, stretch and release. And as it does so, the interior rubs against each other. And just like you might do on a cool morning, rub your hands together to warm them up. As the insides of Io rub together, they heat up. And this is adding a tremendous amount of heat to Io's interior. And the best way for it to escape is through volcanoes. And that's how we end up getting a tiny moon like Io as the most volcanically active object in our solar system. All right. So we're going to leave our solar system now and head on to a couple of other planets. We have found thousands of planets around other stars in our galaxy, and some of them are weird. So we're first going to head over to 55 Cancri E, which is nicknamed the Diamond Planet. It gives it away a little bit, but hopefully you still are interested here. So 55 Cancri E is a rocky planet that orbits around the star 55 Cancri. The E is just designating which number planet it is. The system has multiple planets. Now, this whole system is located in the constellation of Cancer, about 41 light years from Earth. A light year is the distance that light travels in 1 year, and that's about 6 trillion miles. So, this planet in particular is what we call a super Earth. So, it's about 2 times the size of Earth and about 8 times the mass of Earth. And so it's still rocky like Earth, but it's a lot bigger, a lot more massive, so we call it a super Earth. Makes sense. Now, as you can see here, and this is an artistic interpretation of what the surface of the planet might look like. We do not have good enough telescopes yet to actually get detailed images of the surface of other planets. But what we do know, and the reason we think it might look like this, is the planet is incredibly close to its star. It orbits its star once every roughly 18 hours. The Earth takes 365 days to orbit our sun. So having that very short orbit means it's very close to its star. And so we estimate that surface temperatures are close to 5,000 degrees Fahrenheit, which means the surface facing the star is going to most likely be molten. And that's why we see all of that red. That's the molten rock that we think is covering the surface of this planet. Now, if you remember, we had a nickname for this planet. We think, based off of how much mass there is, how big it is, that a good bulk of this planet is made of carbon. And inside the planet, it's going to be under very extreme pressures. So extreme that we think that carbon might get squeezed into diamond. And as much as a third of the planet may actually be diamond. Hence why it's nicknamed the Diamond Planet. Now, we don't know for certain that these conditions are met. There have been some other studies that have come out that have slightly different parameters for the planet that come to slightly different conclusions. But until we know for sure, I think it's really fun to just think that there is, a planet full of diamonds out there. All right, our next stop and our last planet of the evening, we are heading over to the planet K2-18b. Again, not the best name. A lot of times we get kind of boring names for things, especially when we have thousands of planets and stars to name. A lot of times they just start getting letters and numbers. So this system here is located in the constellation of Leo, and is about 124 light years away. Now, what has us interested, or initially had us interested in this planet here, is it's within what's known as the habitable zone, or the Goldilocks zone. Basically, this is the region around a star where the temperatures would be just right for liquid water to exist on the surface. In other words, the temperatures would be Earth-like. We might have Earth-like conditions on the surface of the planet. Now, this planet here is another super Earth. It is, again, about twice the size of Earth and about 8 times the mass of the Earth. But since it is rocky and within the habitable zone, there is a chance that there could be liquid water on the surface, and we might have Earth 2.0. Now, when we first discovered the planet, we didn't know for sure what the surface might look like. All we knew was the size and how close it was to its star, which helps us figure out the temperature. But then in 2019, we detected an atmosphere around the planet, and we detected water in the atmosphere, which seemed like a huge check. Yes, we see an atmosphere, we see water in it. This very well could be a new Earth here. Unfortunately, we don't think that's the case anymore. We now think that this planet might be more like a mini Neptune, which is another kind of odd type of planet. We don't have something like that in our own solar system. But we think that it actually has a really, really thick hydrogen atmosphere, which would make it too hot for life, for any Earth-like conditions on the surface of the planet. So instead of having an Earth 2.0, we have this weird mini Neptune, which is also bizarre because we don't see a lot of those, and we definitely don't have one in our own solar system. So we don't know much about this type of planet and what it might be like. So we're going to continue studying it and hopefully learn some more about it. It doesn't mean that it couldn't possibly have aliens on it. It just means that it's not our Earth 2.0 like we initially thought. All right, let's head away from planets now. And we're going to head over to a nebula. Now, a nebula is a giant gas cloud in space. The one we're heading to is the Red Rectangle Nebula. Very obvious name. It's red and it's rectangular in shape. This nebula is located about 2,300 light years away in the constellation of Monoceros. I always struggle to say that name. It's a unicorn. If you didn't know, there is a unicorn constellation, and I love it. This is a weird nebula. So it's what we call a planetary nebula. This is what happens when a small star, about the size of our sun, dies. I'm going to show you a quick kind of animation here. So when a smaller star gets to the end of its life, it kind of puffs up. And the outer layers of the star eventually get so far away that the gravity is not strong enough to hold them in place, and they just start kind of puffing out and away. And you end up with most of the gas of the star leaving, and it surrounds the dead core of the star that's left behind, which we call the white dwarf. And so while this gas is hot, it will glow, and we see it, and we call this a planetary nebula. Now, as you can see, we pull up some other images of other planetary nebulae. As you can see, they are normally circular because stars are spheres, and when they puff up, they're still spheres. And so when the gases fly away, they fly out roughly the same in all direction, and so you get gas clouds that are spherical, at least mostly. And that's why the Red Rectangle Nebula here is so strange. It's this weird shape that we don't expect to see from a planetary nebula. Now, there have been some suggestions of what could possibly be going on. One possible idea is that maybe there is like a disk of debris around the star, so that when it started to puff up and blow out its layers, that stuff got directed up and down and couldn't really pass sideways through that disc. That disc kind of acted like a blockade, and it funneled the stuff up and down rather than outward. And in some of our simulations, we can kind of get the shape, but it's still very angular, very boxy, and we can't quite figure it out yet. So that is the weirdness of the Red Rectangle Nebula. All right, one last thing in our galaxy before we head out. We are going to head over to a globular cluster. Now, a globular cluster is exactly what it sounds like. It is a giant glob of stars. It is a big star cluster that generally has tens to hundreds of thousands of stars within it. And they're kind of packed into a roughly spherical shape. And they're really cool looking, and they have so many stars in them. We study globular clusters because the oldest stars in our galaxy are in them. So those were some of the first things to form when our galaxy formed. And so they help us kind of study the formation of galaxies, since those were the first things to form. I feel like I said form a lot there. Anyway, this particular globular cluster we're looking at is called Omega Centauri. It is located just over 17,000 light years away, much, much further away than anything else we've looked at so far. And it is the largest globular cluster in our galaxy. So to give you a comparison, here in the middle, I'm going to put an average sized globular cluster. So there is your average sized globular cluster. And this is Omega Centauri. It has an estimated 10 million stars within it. Remember I said on average a globular cluster has 10,000 to a few 100,000 of stars. This has 10 million and is generally, at least 10 times bigger than globular clusters normally are. It's a giant. It is an absolute giant. So this has caused, some head scratch and some questions. How do we possibly have a globular cluster this gigantic? And this one we do think we have an answer to. And that's because we think that it's not actually a globular cluster. It turns out that this is likely the core of a smaller galaxy that our Milky Way galaxy ate. Galaxies grow by accreting, by combining together to make bigger and bigger and bigger galaxies. And sometimes when you have a really big galaxy like ours, acquire a smaller one, you can get the outer stars that kind of get pulled out and away, but the core of it is held together strong enough that it kind of stays together. And that's what we think happened here. We think that this is the core of a dwarf galaxy that merged with the Milky Way, and it's all that is left. All the rest of the stars kind of got pulled away and are incorporated into our galaxy in other places. And just because we can, I should have played this earlier, but we have a gorgeous kind of pan through this cluster here. We're looking at kind of the outer edges and then moving more towards the center. There's just so many stars. It's kind of crazy. All right. Now, for our second to last bizarre object, we are going to head out of our galaxy into, jumped a little there, into the universe of galaxies and take a look at something known as Hoag's objects. Now, in order to really understand why Hoag's object is bizarre, we need a little bit of background. So first, let's talk about galaxies. Galaxies typically come in three types. We have elliptical galaxies. We have spiral disk galaxies. That's what our Milky Way is. And then everything else is considered an irregular galaxy. These are galaxies that don't fit the other two categories, and they're generally galaxies that are in the process of merging or interacting with another galaxy. And so that gravity has kind of twisted and distorted their shapes. And eventually they'll settle back down into either an elliptical or spiral. We're just catching them mid-chaos. So let me show you Hoag's object. Hoag's object is a very rare type of galaxy called a ring galaxy, because we have a central area that looks like an elliptical galaxy, but then it's surrounded by a ring of young stars. That's why it's blue in color. Now, this particular shape is not something new. We can get these kind of ring shapes thanks to something called gravitational lensing. And so let's watch real quick a little bit, or sorry, on the left there, you can see some gravitational lensing, and it looks very similar to Hoag's object. Now let's learn what gravitational lensing is real quick. I have those two buttons backwards.
This same light bending leads to the warping of light from
sorry.
as the light encounters supermassive galaxies on their path to us. This is called gravitational lensing. Here's a clip that shows how this lensing works on a grand scale. A distant galaxy would be seen here on Earth directly if there were no intervening massive cluster to bend the light. But with such a cluster, the light from the distant galaxy is bent into rings and arcs to continue on to the Earth. This is Abel 1689, 2.2 billion light years away. It's one of the most massive galaxy clusters known. The gravity of its trillion stars plus dark matter acts like a 2 million light year wide lens in space. And here's another cluster, 5.7 billion light years away. It's the latest from Hubble on gravitational lensing, released in late 2015. These foreground galaxy clusters are magnifying the light from the faint galaxies that lie far behind the clusters themselves. These faint lensed galaxies are around 12 billion light years away. It's the gravitational lensing that allows us to see that far back in time. Without the magnification, these galaxies would be invisible for us.
So, gravitational lensing can produce galaxies that look like a ring. But we know that these two parts are two separate galaxies because we can tell that in the light. We can figure out how far away both of these parts are, and we learn that the ring here is much further away than the central part. When we did this with Hoag's object, they are the same distance, meaning this is not gravitational lensing that we're seeing here. This is the actual galaxy is shaped like a ring. And we are still trying to figure out how a galaxy like this can form. We do know that the central part is older and the ring is younger based off of the stars that we see there. So maybe we have just a weird galaxy merger that created this, but stuff like mergers tend to be very chaotic, and you don't get systems like this out of that. So yeah, we don't know. And we have found a couple of other galaxies that look similar to Hoag's object, but it is a very rare new type of galaxy that we are finding and still trying to understand what's going on there. All right, our very last stop tonight is going to be at the supermassive black hole at the center of our galaxy. Now, the supermassive black hole at the center of our galaxy is named Sagittarius A star. It has about 40 million, not 40, sorry, 4 million worths of suns inside of it. Now, black holes come in different sizes. And we see small black holes, which we call stellar mass black holes. And then we see giant ones like this at the center of galaxies, which are the supermassive black holes. We know how stellar mass black holes form. They are due to the death of massive stars. When these massive stars die, they explode in what we call a supernova, and that center will collapse in on itself. And if there is enough mass there, it will collapse so far that it will create a black hole. And a black hole is just a region in space that has so much stuff packed into such a small volume that the gravity is at its most extreme. Not even light can escape from it. So we have stellar mass black holes, which form from the death of massive stars. And then we have the really, really, really big black holes, or supermassive black holes. How do we get there? Well, one possibility is small black holes merge together to create bigger and bigger and bigger ones until eventually you get a supermassive black hole. If that was the case, then we would expect to see a middle point, somewhere in between. Because as it gets bigger, you'll have an in-between stage there. So we call these intermediate mass. And we have started to find some intermediate mass black holes, which suggests that this might be how they form. However, as we're looking at very, very young galaxies, really early on in our universe, we are finding that they show up a lot sooner than they should if this is how they're formed. Which means there has to also be another way. And we have no idea what that other way would be to create these monsters, black holes at the center of galaxies. But it has to be a common process because pretty much every galaxy we see has a supermassive black hole at its center. So they are common, but we don't yet know how they form. And to end us off, astronomers with the Event Horizon Telescope have captured some of the first ever pictures of black holes. This is Sagittarius A star, the black hole at the center of our galaxy. And then this one is the supermassive black hole at the center of galaxy M87. And they may look similar in size, but the M87's black hole, ours would fit, right in there. It's much bigger than ours is, which isn't too surprising because it is a much, much bigger galaxy. But yeah, puts ours kind of to shame there, and we don't know how they're formed. Hopefully we will soon, but for now, these monsters will remain a mystery. All right, that is the last of our bizarre things that we are going to take a look at this evening. I'm going to turn our lights up here. And thank you. See. Thank you. Are there any questions? Yes. You do? What do you know? Mm-hmm. Yeah. Yeah. Black holes in general are a big mystery. We don't really know what's going on inside there because our understanding of physics kind of breaks down. And so we have to get a better understanding of physics at these weird circumstances and these weird conditions to hopefully figure out what it's like in there. Yeah. All right. Well, I was told by Rachel that they do have the telescope set up outside. It is a little cloudy, but they are getting views of the moon. So if you have any other questions